Okay, so basically, the Bluetooth SIG is basically playing around with a new security model for Bluetooth since, let me guess, something like 1.5 years. And half a year ago
Sorry.
Okay.
This works.
That works now?
Okay.
Is this enough? Well, it should be enough. Good. So the Bluetooth SIG is playing with a new security model since 1.5 years now, and since half a year they have a new specification around that's available. And I'm gonna go a little bit over the details, what they've done, what they're doing, what they try to solve, what, under my opinion, they did wrong, and what we're gonna see with it when it comes out. Actually, this is totally annoying. This is the only problem with your first speaker in the morning and this room hasn't been used. Never mind. Okay, so besides the new security model, they ended up, okay, we need something to make it clear what the device can do and what the device can't do. So they have these nice number of icons, which ends up, okay, yeah. The left one is basically, okay, you can use a keyboard or a mouse and you know, see, okay, this will work. Second one is you can play high quality audio, great. The third one is the kind of headset, it's kind of lame. The fourth one is a printer, and the fifth one is file transfer. The best one is actually that the mouse has a cable. We're talking about a wireless technology, and when you ask them, oh yeah, otherwise nobody will realize that that's a mouse. But never mind. So anyway, if you talk about security, they look a little bit differently. And at some point we have to actually tag devices with these kind of icons in case of their security implementation. But that's just as a side note. Okay, to see the difference between the security design in the old specifications and the new 2.1, actually go quickly over what they currently have done. They have 3 security modes. I'm going to go into them a little bit in detail on a later slide. They had the problem that they had basically, when Bluetooth came out, which is around 99, they had the problem that the chips were kind of slow, they had limited resources, and so they had to invent a lot of stuff by themselves. Meaning they invented their own encryption algorithm and they used Safer Plus and modified it a little bit so that it's not reversible. They stuck with 128-bit for the encryption keys, which is actually perfectly fine since we're talking about small devices that actually move and you don't want to really protect something like really trade secrets or whatever. Anyway, the interesting part, they have a handshake pin code basically, which is 1 or 16 bytes long, which is kind of strange, so actually you can define its size. And you end up with a 128-bit encryption link key that gives you the authentication and will be used for the encrypting the link between 2 devices. The good thing is they separated the host operating system interface from the link manager that actually does the encryption for you, which you see on this slide. Basically they separate everything. So what you have on the lower layers, that's a piece of hardware, which is a Bluetooth dongle, Bluetooth chip that you build in your phone, etc. That does all the crypto algorithm, that does all the authentication, that basically does everything. On top of it, you have the host security, which basically is, oh, I have to pop up a dialog and ask the user for a PIN. That's all what the host stack basically has to do. And then on top of it, you have applications that say, okay, yeah, but that's not secure enough, so I'd use SSL, TLS, or whatever on top of it, but it's basically their choice. But all the hard part is done in the hardware, so basically whatever host stack you use, they can't do it wrong. The only exception is we've seen that they did it wrong. Probably everybody remembers the Nokia 6310 phone, which actually screwed it up totally. I forgot one to mention, the host stack has to actually decide when to enable the authentication and encryption, since there's still some use cases where you don't want to have an authentication and encryption, especially do you want to do an anonymous transaction, etc. With the old security mode, they had 3 security modes, which was basically not a bad idea in the beginning when they designed it. So security mode 1 was basically, okay, we don't do any security, except the other side wants it. Which means if the other side decides to have to do any security, meaning authentication or encryption or both, they have to follow it. So otherwise they don't have any connection, which basically means one side says, I don't want to do security, and the other side says, okay, I go along with it. It doesn't work this way. If one side wants security, then they have to agree on it, which is a bad foundation to start with. Security mode 2 was, okay, we basically go without security, but if you have a service like synchronization profile where you can sync your contact database and so on, yeah, then we have to do authentication and then we do have to do encryption later on. That sounds reasonable. Basically, which means it's based on security mode 1, so security mode 2 is an extension. The only big problem then is ended up, okay, then we do security mode 3. We always authenticate and we always encrypt and we do this on the chip level, so the host stack don't has to do anything. For some reason this mode ended up with being, okay, this is the most secure mode, and the specification was written that way. It said it literally, which was simply plain wrong, because then you trick somebody into an authentication and into an encryption, tell them you do a business card exchange, but you actually read the complete phone book and they don't even know it. It took something like 4 years to tell the BlueZ actually to change this and to remove this phrase from the specification, and in the end deprecating that mode. Okay, so this is the piece of thing that the host stack has to do with a Bluetooth 2.0 or earlier device. You get a request, I need a pin code. You pop up your dialog, user enters pin code, you send the pin code back to the chip, and then you get a link key. That's it. You store the link key for future use. It's basically 16 byte, 128 bit. So next time you come in, the chip asks, oh, I need a link key. Oh yeah, I have one. I've stored this safely in my Windows registry or on Linux on the file system or somewhere else. Oh yeah, here. And they say, okay, you're connected, you're authenticated, you can enable encryption, and so on and so forth. Sounds pretty simple. Nokia screwed that up initially, Sony Ericsson screwed that up, and a lot of companies did this really wrong, because if you don't tell them that you want to have a secure link, then basically this transaction never happens and you go unauthenticated. I think it's quite clear to everybody. Who has any misunderstandings how this works? Sounds pretty simple, doesn't it? Okay. So, we had a couple of issues with this model. Especially, you have to enter the pin code. How are you going to do this on a headset? Or on a mouse, for example? Any good ideas? We came up with Morse codes, but then you have the usability people say, not so many people can do Morse codes, and it looks kind of stupid if you have to enter a 16-digit pin on a mouse. So it doesn't work that well. So what it ended up is, these devices like headsets, mouse, and all the other small devices which have basically no keyboard or no input facility ended up with they use fixed pins. Okay, let me put it this way. A headset that has a fixed pin is always visible, is always connectable, and you can always pair to it. There's another word for this one. Does anybody know? We call, in the intelligence business you would call this a bug, but basically you're right. It's a perfect thing. So basically you end up, oh, you're nice CEO, I have a nice present for you. Here, take this headset and go into your special meeting where you're going to sell your company and sit next room and hear everything about it. So let me put it this way. I had a company that wanted to actually sell one of these. And they said, no, there's no security issue. And then we ended up, okay, sitting next to them and actually recording one of their conversation and playing that back to the one guy that was in charge at that event. He got a little bit scared. The other issue, what some people ended up with, the pin codes that were used could be brute forced in the end, up to something like 8 digits. So if you have an 8-digit or less pin code, you ended up with something like 2 or 3 seconds to brute force the pin code and create the link key out of it. So it was not really secure enough. Welcome to my screensaver. The other thing, which was basically design flaw, the link keys that you get have no expiration date. You never have to renew them. So once you're paired with one device, you're paired for that device for the life, except you lose your link key. It's kind of, okay, they should at least be renewed at some time. Some devices were going in a way, there is a way to update the link key and create a new one. Some devices were actually starting using it. But the majority of the Bluetooth stacks and Bluetooth devices were not, so the link keys were valid forever. Which means if you get hold of this link key, however, and then you have the Bluetooth address of the other side, you can create a perfect clone of the device and access all information. The other thing that's basically unknown is the unit keys. There were unit keys for the early days which got, okay, we have a fixed unit key in the device, another key in that device, and they are bond together so they can always communicate in a secure way. The unit keys got deprecated a lot earlier, and some devices don't even support them anymore. What you currently see is called combination keys. The other thing, potential reply attacks. Yes, you can actually, if you can sniff a connection and see the data, you can try to reply it and then get access to the devices. It's not protected against man in the middle and other things. Some devices don't implement pairing mode, which is kind of not obvious, but the initial specification said, okay, if you want to do pairing, you have to press a button or say something that you're explicitly in pairing mode. This got removed by most manufacturers because of usability features, because it was too hard to tell them, okay, you have to press this button of the headset for 3 seconds, otherwise you can't pair again. So they simply said, okay, that's not usable for the normal user, it's too complicated. The authentication abuse I actually mentioned a little bit. So once you have the link keys or the security for all Bluetooth devices are per device, not per service. Even if you have security modes 2, which is service level security, you only generate one link key and it's valid between 2 devices. So once you have access to a device, you have access to every service, except you implement further authorization. And I mentioned before, security mode 3 is not the safest, whatever the specification says. Okay, that's the basic design issues. Then we have implementation issues. I think everybody heard about BlueZ and BlueBug, the original attacks, something around 2004. Who haven't? Good. Actually, the funny thing was this, I think BlueZ even made it into one English dictionary in the end, so it is a dictionary, but it's totally ridiculous. The other thing, backdoor and social hacking were actually really simple because it was too complicated that people had no idea what they were doing, and they got talked to that, okay, press 4 times 0, then hit enter, and that will work in 99% of the times. So that's what they're doing. Even if someone totally malicious attacker comes along and says, okay, please give me access. Oh yeah, that we have to do 4 times 0, enter. And you get away with it. Some companies have basically no idea how Bluetooth worked. They're getting better, but initially they were thinking it's kind of infrared, and we have it now over the with wireless technology, with radio technology instead of something else, and still we have to put the devices inside, and we only can be 10 meters away, and it won't work over a mile and stuff like that. And you probably have seen all the tests we've done where we actually put in a direct antenna to it, and then you can do attacks over 1 mile and stuff like that. So the mind changes in these companies, but it changes slowly. So we do want to address this problem, and the BlueZ decided, okay, we do something. It took them way too long to realize that they have to fix this. The only problem is the Bluetooth specification is written always in a way that is completely backward compatible, which is kind of tricky, and we will see how tricky that is. They wanted to do something fancy, since they wanted to improve usability, so they want to do, if we put 2 devices close enough together, then they're basically automatically paired. So if I take my phone and take my computer, I simply have to put the phone on the computer and they will be paired. Let me put it this way. I have no idea when this will actually come to the market, but they're playing with this for something like 2 years now and haven't seen only prototypes, and the best prototype they came up with is you take your picture with your phone and then you hold it to a frame, and then it transfers the image to the frame, and then you can display it and say, woohoo. I don't need any security for that, I don't care about that. It's basically, yeah, I want to have this picture on my frame, and if somebody changes the picture on that frame at my home, yeah, they have to be so close that they have to break first in your house, and then they go something, yeah, maybe I steal something, instead of only changing the picture. Never mind. It should be easy for the end user. They really want to make it easy, but on the other hand, it should be secure, which means just putting 2 devices together should be more secure than what we currently have. Kind of tricky. Okay, which ends up, we have to fight with usability, security, and complexity, and that's basically unsolvable. Okay, usability says pin code entering or passkey entering is not intuitive. I agree with that, I don't want to enter a number. I mentioned mouse, headset. Some devices you can't actually enter a pin code, so yeah, we have to figure out how to deal with them. Security. Oh, the new method should be more secure. they had at least a good intention. It should be extendable, so we can do something like NFC or some fancy method, or if you plug in a cable first, then you pair yourself automatically and stuff like that. As I say, the ultimate security in this case probably doesn't exist if you have usability in your other mind, because it increases that much the complexity, which ends to my last point, that people will screw it up. And I go over a couple of slides now, and the model gets a little bit more weird when you go with that. Okay, they kept the word pairing for some reason and called it simple pairing. At some point they realized, okay, simple pairing is from a marketing perspective bad. So they ended up, oh, we have to call it secure simple pairing. Never mind. The good thing is actually they went on their roots and said, okay, what do we have in the security business that actually works? So they went up elliptic curve Diffie-Hellman. Okay, that's nice, at least public key exchange instead of their homegrown stuff. They have a passive eavesdropping protection and an optional man-in-the-middle protection. The eavesdropping protection is mandatory, you can't switch it off. The man-in-the-middle is optional because they wanted to have two models. It just works, so you put devices together without any user input, and then you have more security than you currently have with the user input. But if you have user input, so the user confirms a PIN code, enters a PIN code, or you have some external mechanism, then you can have an additional man-in-the-middle protection. That's not a bad idea. The encryption is still on the chip, which is good, so nobody in the host stack business can actually screw up the encryption algorithm and make their bugs, and include bugs or weak implementations or whatever. They ended up something like I/O capabilities. I have a couple of slides for that go that in detail, which means basically, okay, the device tells you if they have a keyboard for PIN code input, if they have a display to show PIN code, or stuff like that. They stuck with the security mode concept. I told them a year ago they should simply deprecate all security modes and have a nice chapter about how security should be done. No, they had a new one, which is called security mode 4 now. But never mind. Okay, I/O capabilities. The basic ideas, a device tells the other device what they can do. If they have an input device, so keyboard or keypad or whatever, or if they have an output capability, so it can display actually something. So a keyboard, for example, has an input capability. A mouse has no input and no output capability, but a computer basically has input and output capabilities, and a display, like a picture frame, has only display capability and stuff like that. So they separate these, and based on these informations, they pick a different algorithm. The first one is numeric comparison. So both sides display a number, and you compare this number and say, yes, they match. You have a passkey input, like before. So one side asks you for a passkey, and then you can input it. It has a slight variation. So there are two ways. Both sides has to enter the same PIN code, or one side displays a PIN code, and you have to type it on the other side, which is kind of nice. For example, if you want to put your keyboard to your computer, so the computer displays a PIN code, and then you only have to type it on your computer, and then you are paired, which is kind of nice. The third one is out of band, so like near field communication, you put two devices close enough together, and then you can basically be paired. And it's meant for NFC communication, but it can be reused for something different. The thing that they didn't do is cable-based authentication. If you heard about wireless USB basically works, you have to put in the device via a cable first, and then you can use it wireless. Of course, Bluetooth is a complete wireless technology from the beginning, so the cable-based authentication got removed from the spec because of marketing reasons, because otherwise it's a cable technology again. Never mind, but with the out-of-band mechanisms you can actually implement a cable-based authentication on top of it, so it's kind of tricky. Hello? Next? Not again, come on. Okay, so the specification is kind of clear how you map the I/O capabilities. So basically they have this nice chart where you end up, okay, oops, don't kill myself, where you have the no input, you can have a yes, no, or you have a keyboard. So they separate between the input capability if you have two buttons or if you have a full keyboard, which means if you have a full keyboard, you can enter actually a PIN. When you only have a yes, no button, you can only confirm that the PIN code is correct or not correct. For the output part, you basically have no output, so you have no display like a keyboard, or you can display actually a numeric number that somebody has to type. And in the end, they ended up, okay, the numeric number is only 4 digits, since that's enough entropy to actually create a most secure enough link key for the authentication and encryption. Okay, any questions for that so far? It's kind of a lot of information up front. And there's a lot of more is coming. And this is how the new security architecture looks like. Yeah, yoo-hoo. They made it a little bit more complex, but in the end it boils down which way you're actually going to do. So Bluetooth in-band describes basically that you do the pairing with a numeric comparison or passkey input, while the out-of-band actually has multiple ways to actually do it while you discover the information, while you have the information up front, and so on and so forth, which makes the model kind of complex. Let me put it this way, I don't expect to see really out-of-band devices in the really near future. They have to solve first the in-band stuff to get that right before they're gonna actually do the out-of-band stuff and think about it. I have this slide in the presentation. You can basically grab it from the specification, but once you see the specification, you get kind of scared. This is basically what it boils down, and then you have the different ways: numeric comparison, passkey entry, or the just works models if you don't have any information. And it is kind of stacked. So you can initially have a just works with a weak link key, and after that you can update your link key with a passkey or numeric comparison to make it more secure. So the example for that one is basically you connect to another device and you have no idea what you're going to use on that device, but you want to have it more secure, so you want to have authentication and encryption. But you don't have any information if they have a display attached or if the service needs a man-in-the-middle protection or whatsoever. So basically connect to it, you do just works, which will give you the Diffie-Hellman public key exchange and the passive eavesdropping protection. But then you want to use a service like, I want to synchronize my phone book. So you want to be protected against man-in-the-middle, then you have to update your link key with a numeric comparison or passkey authentication. Works pretty well, but it's kind of makes it more and more complex all over time. Any questions to this diagram? I answer them happily, but otherwise I simply go to the next slide. Are you scared? Confused? Okay. As I said, initially the link key was basically everything. And the combination key, I mentioned that's the basic link key. Then they had the local unit key and remote unit key. Both are deprecated, but they're still in the spec. And okay, we have this new security model and we have to differentiate the link key because we can't tell what link key it is. So they have the new types like debug combination key. I'm going to go on the debug combination key a little bit later. Unauthenticated combination key. That's basically what you get if you do just works. And authenticated combination key if you do passkey entry or numeric comparison. And a change combination key if you have used an authentication combination key and changed it, so you update it over time. And all of these link keys have different implications on when you have to drop them, when you can use them, and what you can do with them. So basically, the debug combination key should only stay in memory. The unauthenticated combination key needs to be updated once you need a higher security level. So means you can store it, but you shouldn't store it since you can always regenerate them in time since it requires no user interaction. The authenticated combination key, however, that's a real one that you want to keep because otherwise you have to do the passkey entry or the numeric comparison again. And the change combination key is, yeah, what do we do if we don't actually know from what the change came? Okay, more confused? Yeah, I was initially, completely. Let me put it this way, they have another nice slide which actually tells you what you have to do and sometimes what you can do. It is not clear if your security requirement from your application is not enough what the stack actually is doing. And just for the fun of it, and I want to show my sliding windows, this spec goes into something like generic access profile, security aspects, security modes, yada 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 yada. Let me just see if we find this one. And then you go into these kind of graphics on the right, and that's not the only one, there's another one. And they have a couple of more. And there are a couple of more, even with reds written in there and whatever. and more and more and more. If you want to ruin your weekend, just have a look at them and try to understand them. They are really complex, and mainly they are so complex because they have to take care of the other devices, not a 2.1 device, and can't do any kind of advanced simple pairing. So you basically have a lot of things to take care of and do it right and make the right decisions. The specification is basically designed as a complete state machine, but they have a state machine that needs at least something like 4 pages on a DIN A4 to describe it. So how can the programmers actually get it right in the first step? Depending on the link type, you have to do different decisions if you have to update your security or if you get a connection request from an unauthenticated device, etc., etc. Some interesting things is automatically initiate pairing, automatically update your pairing, notify the user, or pick whatever you want to do and stuff like that. None of them actually speaks about when you have to disconnect the device because the security requirement is not enough, which is kind of, I think it's a weak spot in the specification at the moment. So my phrase is, there's nothing simple when it comes to secure simple pairing. The word simple isn't there. The word simple, it makes no sense. It's marketing crap. The word secure is marketing crap because simple sounded not secure enough. So we have a lot of stuff they build around the word pairing for no obvious reasons. Okay, the only good thing is it is more secure than the current model, even with only just works. It is harder to get into the connection, it's harder to spoof the connection. And the main reason, since they always enable security, meaning authentication and encryption, it is definitely a way in the right direction. The only problem is, if you want to have the real security, it's getting a little bit more complex. And I just sat down a couple of minutes ago and actually draw this small graphics. So basically the legacy pairing looks like this. We have this big chunk of cryptographic information, authentication technologies, key handling and so on. That's a Bluetooth chip. We have a little bit in the host stack. You see they have to open the dialog, store the link key, etc. And we have an application that actually have to decide if they want to do security or not. Okay, that's pretty simple. Once you go into simple pairing, you put a little more technology in the chip. Okay, the chip manufacturers are not too bad. Most times they know what they're doing. Then you basically double the information you have to deal in the host stack with, and you even increase the information in the application, because the application has to know, okay, what's the current security situation? Do I have to update it? What information I have to tell them? Do I want to have a man-in-the-middle protection? Do I want these? Do I want that? So they double in every place instead of making it really simple in one place, but they put the pressure on this. And the biggest problem is the host stack to get it actually right, since that's separating the applications from the Bluetooth chip and having the major attack vectors. Okay, you just saw basically how the legacy pairing works. This is a secure simple pairing with user confirmation, where the basic user gets a PIN code on both sides and have to say yes or no. Let me put you through this. Basically, they exchange the IO capabilities, yada 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 yada. And then they have their confirmation request, then their passcode, and then the host stack has to display this passcode somewhere, and then they have to wait for the confirmation for it, and this has to happen on both sides. And in the end, you finally get your link key, which you got initially. In this case, you have the authenticated combination key, which is the most secure link key you can get. And let me put it this way, this is the simplest version of simple pairing in its implementation way. If you go in that you have a just works model where you have to reject the previous link key because it's not secure enough, and then you have to do this again, and so on and so forth, and not even speaking about the IO capabilities, since sometimes you have a keyboard attached, then you could input a pin, sometimes you don't. You have to check the IO capabilities, have to match your security requirements, and so on and so forth. Okay. Got any scoops when I said it has a debug mode? Yeah, me too. So the problem with the secure simple pairing is it's too good. From a cryptographic standpoint, it's too good, and it's too good for the protocol analyzers. And the companies that make money with their protocol analyzers to sniff connections between devices have a big problem. They can't anymore. So I said, yeah, whatever, who cares? The Bluetooth SIG decided, okay, we have to play nice with them. So then, okay, we have a debug mode. A debug mode basically defines predefined keys in the cryptographic sequence that are known to the chip will enter the debug mode. Okay, it's fair enough. So if you see these keys, then you have a debug connection and then you have to deal with it. I said, okay, it's fine. Both sides say we are now debugging, not a big deal. The only problem is it ended up not only the chip has to know about them, also the host stack has to deal with them, which means the host stack sees these debug keys, which is kind of bad since they have to do the right handling. If you trust a debug key, then you basically trust a debug key. But then I said, okay, if one device then gets out of debug mode, then the debug keys gets invalid. Wrong. The specification says only one side has to enter the debug mode and the other side has to follow, which kind of, why? And yeah, because we have to, it's complicated with the UI on the headsets to actually tell them to debug mode. You're debugging something. If they have to press Morse code to get into debug mode, I don't care. It's not for general use, it's for the engineers. No, they want it easy for everybody. So remember, for any people that implement a host stack, you really have to take the debug link keys seriously because they are a big security risk. I tried to tell them that's wrong and I don't care, but they ended up, this is the specification how it stands today. Oh, and by the way, I've seen some early chips that got confused once you have enabled debug mode and then switch out of debug mode, then they still produce debug keys all over. But never mind. But that's probably fixed by now. Okay. Bluetooth 2.1 is out since middle of the year. I haven't seen any device so far, and every time I speak to actually companies that work on Bluetooth 2.1 stacks and Bluetooth 2.1 devices, they are scared. They don't want to put it out on the market. Nobody wants to go first. They're testing interop with old devices and they're testing the complete functionality and they have a big problem. The chip manufacturers have all 2.1 ready chips, but none of them is actually really selling them. I think CSR is selling some of them, but I haven't seen that on any product. And they even don't have a firmware release they consider from the quality-wise stable enough to actually do it and announce it officially. Microsoft has a stack, Broadcom has a stack which supports 2.1. They both are not convinced that they're going to release it, so I don't know what happens. Apple is not doing it at all, what I know from a current standpoint. The Linux side is fun. Since the first stack I had ready something a year ago, then the Bluetooth SIG decided to change the specification completely, so that implementation was invalid. Then I tried it again with a beta specification. It ended up being full of security holes when I did the audit on it, and currently I'm working on the third generation of the Bluetooth 2.1 implementation to get it actually right, and I have no idea when it will be ready for mainline consumptions. So, I have no idea when we see the first devices. My guess is a keyboard, a really simple keyboard would be the first device we're going to see, but who knows. Okay, just to sum up the possible issues which 2.1 involves, the debug mode, it's a big one. If that goes screwed up, then you basically have really weak devices. The interop with old devices has such a high priority in the whole specification that I don't know if they always get this right. As I showed, the complexity gets more in the host stack, and you know what happens if manufacturers have to do all them by themselves, they screwed up. They screwed up even with the older Bluetooth profiles, which was pretty simple. I know they have to do even more to make it secure. I don't know. The higher level protocols actually can do security evaluation and change the behavior, what they have to do again, etc., etc. I mentioned it, the missing I/O capabilities don't enforce a disconnect or rejection, so you basically can get away with it and expect an authenticated combination key, but in the end you get an unauthenticated combination key and you go along and you are basically not protected against man-in-the-middle attacks, which is kind of okay. If you want that protection and the other side can't serve it, then you basically have to disconnect. But then you go again, the usability, oh no, we can't disconnect because the reason is not available, not easy to display to the user, whatever. The specification changed in the last months before it was released so many times, and it still changes because of the additional erratas, because they did the wording wrong, they had ambiguity in some of the paragraphs and so on and so forth. So you really have to look closely to see what you have to do if you deal with it. Okay, 3.0 and later. It's fun, it gets better and better. So at some point 2.1 should be the standard for doing the security within Bluetooth, and it's pretty good standard once we get the host stack implementations right, which I currently doubt that it will happen anytime soon, so at least another 2 years. So 3.0 is targeted for the end of next year. It will introduce something that's called AMP, Alternate MAC and Phi Layer. So they wanted to go high speed and decided, okay, yeah, we don't do our own radio again, so we use either ultra wideband or IEEE 802.11. The interesting part is both come with their own security models. Because we can protect the Bluetooth radio quite good, but if you do ultra wideband or Wi-Fi, you have to protect that too. And we know in the Wi-Fi case how that worked out. And they're working on their own security models to protect the Wi-Fi link and the ultra wideband link, and they will end up in having additional link keys that can be used with the Bluetooth stack. So it's all work in progress. They're discussing it forth and back. But at some point, there are too many Wi-Fi companies that had no idea how security works, are actually making proposals which you see, okay, that's simply wrong, that won't work. Never mind. Ultra low power, aka Vibri. So Nokia did the smart move and sold it to the Bluetooth 6, so the Bluetooth 6 has no deal with it to make a proper specification out of it. It's 2.4 gigahertz radio, but it's totally different baseband. Calling it Bluetooth is absolutely wrong because it has nothing to do with Bluetooth. It's some whipped up a radio protocol designed in some Nokia research center in Helsinki, designed by people that get paid for doing weird stuff. I know they try to make a product out of it. It is really that way. The security is kind of the same as this with Zigbee. Oh, we do this later. Yeah, I'm not kidding. It is this way. I would never put this on a slide, but basically there was something, okay, we have to do a protection there, and we use some checksum algorithm, yada, yada, yada. Guys, you can actually brute force this. It takes something like 2 hours. Okay, then we double the bit rate. That's not what I meant. It only takes longer. And I can do it in a week, but it takes probably 2 weeks or something like that. I'm not kidding. They are thinking about stuff like that, but I hope that at some point they get some sense into it and say, okay, we have to be at least same secure as 2.1 will do, so they have to do something. A lot of people say ultra low power is not even needed, but that's a marketing requirement for some more chips to sell or whatever. And most companies don't even want to do ultra low power, they only do it because Nokia pays for it. Never mind. Okay, conclusions. Since I probably have more than 5 minutes left, so I'm not that bad in time. Bluetooth 2.1 is a big step in the right direction. The only problem is the big companies have to get it right. So we have to get a Linux stack that works perfectly. We have to get the Microsoft stack working perfectly. And once Apple and other companies jump on it and actually have stacks, they have to work. The only problem with that is there are no security audits for what actually comes out of it. The Bluetooth SIG has this big testing and qualification and so on, but they don't check if the security actually works. They check basic functionality. That's a big problem. And there's no plans, what I've seen, that they're going to do this. The big complexity of the new design is always a problem, and the more complex the specification gets, the more cases you actually screw it up, and this is what I expect to see happen. There are no really easy use cases that can be generalized. So basically for all the implementers of a host stack that runs on a desktop PC on an embedded system, can be used for different cases, for different scenarios, they have a hard time to get this right. If I have to design a keyboard, that's simple. If I have to design a headset, that's simple. If I have to design a multi-purpose stack, then the problem comes up, and that's basically what the Linux side has to do, what Microsoft has to do, what Apple has to do. And I'm not really looking forward in finding out what actually works and what doesn't work. Okay, that's from my talk. There was a donkey at some point from the usability issues, which is kind of nice story, but I open this for questions now. Go ahead.
Last week on YouTube there was a nice video about some US American university.
The shaking? You want me to speak about the shaking part? Okay. Okay, he just mentioned about the, I think it was last week's, it goes to all the news stickers and was on YouTube. They had a new way to do actually the pairing. Basically, it's kind of out of band mechanism. So you take your phone and probably another phone, borrow your phone, and you do something like this, long enough, and then it's paired. Because they check in a basic same frequency, and that's enough to pair. Actually, the idea is nice. We will see. It's definitely with 2.1 it's possible to implement this kind of out-of-band algorithm to do it. I have no idea if they're going to do it, if someone's accepting them, or if you people see pairing and sitting in the airport and pairing their devices. I don't know. Yeah, he mentioned that you need additional hardware. The phones always get a motion sensor nowadays. The OpenMoko gets a motion sensor, the iPhone has a motion sensor, and it's getting more and more phones get this. I have actually no idea how this ends up, but the idea is kind of nice. So maybe if someone is bored, they're probably going to really implement it with a real device. Any other questions, comments?
You mentioned NFC. I heard a little bit out of it that you don't really believe that this will work out as a pairing mechanism.
Okay, if NFC would work out as a pairing mechanism, NFC will work out. NFC is actually quite nice and good enough. The only problem with NFC, it's still RFID. So if you think it only works in a distance of a centimeter or two, you're mistaken. If you put a big enough antenna on it, you can read it from a more wide distance. The second of all, getting devices with... Wait a second. Wait until your talk. Getting devices with NFC support. Nokia talks about NFC for paying with your mobile phone in trams or trains or whatever since 2 years. These devices never make it on the market so far. The chips, somehow they're not good enough, but I haven't seen this making on the market.
Well, actually, NFC, one model is sold already.
Yeah, I've seen that model too, but
It exists, at least.
I never said they not exist, but they're not mass market. Nokia has one model. That's the only company that actually has a model. Okay, so
actually back to the near-field communication. There's no security. You can spoof it. You can clone it. And especially, I have one of these Nokia phones with an embedded RFID reader, and this is just it's just the EEPROM reader. It's clear text. It's not encrypted. It's not secure. You can clone it. You can spoof it, and you can do everything with it. So near-field communication has to be done with the same type of security. You cannot do it simple. Otherwise, I just clone your tag and get in and get the key.
as I said, it's absolutely true, but we have to see how this works out, and still people think more about usability than actually security. There was another question somewhere. Yes, please.
You mentioned that you don't have an implementation of the stack right now in macOS or anything?
Okay, but there's no implementation in the stack whatsoever. There are prototypes of the stack which Microsoft and some other companies go testing with on the Unplug events, which are covered by an NDA. I don't see anyone of getting out and say, okay, we now do it. Apple said to me, no, we are busy, we are doing something else. The Linux implementation which I'm working on is, yeah, it's not ready yet because there are too many factors I have to think about to get it right. And I don't want to push something that is half ready and basically someone comes along and does an audit on it and it breaks behind my back. Same goes for the other companies. They're really afraid, and I haven't seen anything coming out, and nobody has a commitment to 2.1. Neither an embedded device, neither an host stack somewhere. Everybody is working on it, but the last things I heard, they're targeting end of next year to have them, which is actually kind of bad. Any other questions? Then thanks from my side, and I open the space for the next speaker.